Hi everyone, so this will be the last and final video for lesson 5.2, solving polynomial equations algebraically. This is where we left off, and today we're just going to be solving one or two questions that are a bit more difficult than these that we have solved together previously. Okay, so let's do question number 48 in page 269. So the question says x to the power of 6 minus 26x cubed minus 27 equals 0. Now we will do the exact same thing that we did before. We are going to substitute the x with a variable. And the lowest degree here is 3, so it's going to be, let's say, that 6 m is equal to x to the power of 3. And after you substitute it, it will be m squared minus 26m minus 27 equals 0. Then you use the calculator. You go to main menu again. You go to main menu, you go to A, and then you go to F2, then F1. Then you write what is A, what is B, what is C. A is 1, B is negative 26, and C is negative 27. And then F1 again to get the value, and you will get M is 27 and M is negative 1. So now we need to write it as if we are going, like we solved it. How's that? We're going to write M minus 27 times M plus 1 equals 0. Why did we do that? Okay, so let's say you have this, okay? What are you going to do? You're going to use the zero property to find m. So m minus 27 equals 0, and m plus 1 equals 0, right? M will be 27 and m will be negative 1. Okay, so that is why we write it down that way. Now, we know that m is x to the power of 3, right? So we will leave these that way. We're not going to find m, like the actual solution of m, but we just use the solution to be able to write these this equation. Okay, so now we will substitute m as x to the power of 3 minus 27 and x to the power of 3 plus 1. Now, after we do that, we are going to use this formula, a cubed plus b cubed, a cubed minus b cubed. We're going to use them in order to be able to solve this equation. So we're going to write x to the power 3, where we're finding the cubic roots of each one, and this will be 3 to the power 3. This is for this equation. And then the second one will be x to the power, and okay. Now we're going to write each one in we're going to expand each one of these two, which will be x minus 3 times x squared plus 3x plus 9, then times x plus 1, x squared minus x plus 1. Now we're going to separate in these and write it as like x minus 3 x plus 9 equals 0, or x plus 1, and you will know why we do that later on. Okay, so we separate them in order to be able to solve them. So let's start off with this one, and then we will do this. Okay, so in this equation, we have to first write each equal to 0, and this will be x equals 3, and the second one equal to 0. And we will use the quadratic formula to be able to solve this, which will be, let me write the quadratic formula up there. It is negative b plus or minus b squared minus 4ac over 2a. Okay, this is the quadratic formula. Let us keep that there. Okay, so we know that this is the quadratic formula, right? So we're going to write our terms into that formula. So x is equal to negative 3 plus or minus 3 squared minus 4 times 1 times 9, right? And then over 2a, which is 2. And when you simplify this, simplify what is under the what is in the radical, it will be negative 3 plus or minus negative 27, still over 2. And then negative 27, it can be rewritten as 9 times 3 times I squared, which is 3i plus or minus 3i radical 3, okay? So that is radical negative 27. So our answer will be negative 3 plus or minus 3i radical 3 over 2. Over 2. Okay? Okay, now the second part, which is x plus 1 and x squared minus x plus 1 equals 0. So x plus 1 equals 0, which will give us x equals negative 1. And then we will use the quadratic formula for the second part, which will be negative 1 plus or minus 1 to the power of 2 minus 4 times 1 times 1 over 2 times 1, which is 2. And then that will give us 1 plus or minus 1 minus 4 over 2, which would be 1 plus or minus negative 3 over 2. And then when you use the imaginary number, it will be radical. You will do it like this: radical 3 times I squared. You take the I outside. You take the I outside and write it like that. So it will be 1 plus negative I radical 3 over 2. And this, and all these that I'm going to write down here at the bottom, let us use a different color. Okay, all these are solutions. So negative 1 is the solution, 3 is the solution, negative 3 plus or minus 3i radical 3 over 2 is a solution, and 1 plus negative I over 2 is a solution. Now see how many solutions we have? We have 6 solutions, which proves the point that I shared with you about the fact that we always should have the same number of solutions as the highest degree of the polynomial. And this will be how we solve these types of problems. I was not able to fit this question into the video. If you have any questions about this how I got the answer or anything like that, or any confusions, you can ask me. You can write it down in the comment section down below, and I will be sure to answer your question. Thank you everyone for watching. This was the last video for lesson 5.2. So if you have any questions regarding lesson 5.2 as a whole, you can either email me at educology.help@gmail.com, or just comment your questions in the comment section down below. And thank you and have a good day.